All right, guys. It is that time. It's time for the Unit 2 unit test coming up here soon. So, here's the practice test. Remember, we pretty much make the real test almost identical to the practice test. The only differences are there are no multiple choice on the, well, actually, no, there are no multiple choice on the practice test, and there are multiple choice on the real test. The real test will have 5 spiral review questions before we start, or before you get into the current content. And the numbers are different. Please do not tell me when you take the real test that this didn't help you because there were different numbers. I mean, that was kind of the whole point. I want you to know the math. I don't want you to memorize answers. That's dumb. Okay, so let's get started. Make sure you have your practice test out and that you're following along and that you know what to do. I'm probably going to break this video up again like I did last time because it does take a little bit of time to work these problems. It takes less time to work them than it does for me to explain them, but it does take a little bit of time. So, so here's part 1, and let's go ahead and get started. All right, determine if the given relations are functions. So the first thing we need to know is what is a function. And I think you are probably sick of all of us saying that a relation is a function if each input has one and only one output. All right, so a relation is a function if each input has one and only one output. So, if we look at A, 2 has an output of 1, 3 has an output of 2, 5 has an output of 3 and of 5. So this input has 2 outputs, so not a function. All right, let's look at the table. 1 has an output of 6, negative 3 has an output of 2, 5 has an output of 0, negative 1 has an output of negative 5, 4 has an output of 2. None of my inputs have multiple outputs, so this is a function. And then let's look at C. So C, when you have a graph, that would be very tiring if I went, okay, this one only has one output. This one only has one output. There's only one output in between. It's going to take forever. So you have the vertical line test. You can abbreviate with VLT. And basically what the vertical line test is if I take a vertical line, or a vertical line should only pass through the function once. So if I take my gorgeous ID and I run it through, it should only touch the function at one place at a time. However, at this point, it touches my function 1, 2, 3 times, more than once. Doesn't really matter how many times, it's more than once. So this is not a function. It does not pass the vertical line test. All right, number 2, identify the domain and range of the given graphed functions. So remember, domain is all possible x values. Range is all possible y values. Okay, so for domain on A, I'm going to look at every possible x value. So if I look to the left, my lowest x value is negative 3. There is nothing to the left of negative 3. My highest x value is positive 3. There's nothing to the right of that. So my domain is contained within negative 3 and positive 3. So my domain are the x values such that negative 3 is less than or equal to x is less than or equal to positive 3. So my domain can be negative 3, positive 3, and anything in between. I have a point at all of those values. Okay, so range measures all possible y values. So my y, the lowest y I have is at -2. The highest y value I have is at +2. So my range is between -2 and +2. So I have a point at every y value between -2 and +2. Okay, so let's look at B. So remember, domain is all possible x values. So if I look at this, this is a function that will continue on forever. What's going to happen? This doesn't go just straight up in a straight line. This gets wider as we look at it. So try to remember that when you are looking at a graph like this, you're not seeing the whole graph. You are only seeing a snapshot of it. We can't graph the whole thing because it stretches to infinity. So if I were to zoom out and see more of the graph, what you would see is that this is stretching outward. So if it stretches outward, it's going to eventually touch every single x on the right and every single x on the left. There won't be an x that doesn't have an output. So my domain is going to be x such that x is all real numbers. Normally I would write out numbers, but I'm running out of room, so I'm trying to contain it to one page. All right, so range. A lot of people assume that if x is all real numbers, so is y, and that is sometimes true, but it's not always true. So if I look at my range, again, we're only seeing a snapshot of the graph. So if I were to zoom out, this would keep going and going and going on forever upward in this direction. But as I come down, I see this point at -4. I see where that graph bottoms out. I see the minimum of the graph. Haha, pulling back math vocab. I see that minimum. That minimum of my graph is the absolute lowest it's going to go. I will not have any points below this -4, but I'm going to touch every point above that. So my y has to be greater than or equal to -4. Okay, it's kind of only got a limit on one side. It'll go up forever. There's no limit to how far up it can go, but going down, it's going to stop at -4 and then turn around and go back up. So y is greater than or equal to -4. Okay, number 3 says identify the domain and range of the given relation. So what we notice here is that we don't have any information. We don't have any information on the function. We don't have any information on the graph. All we have is the table. I have nothing else to go off of. So since this is all I have for my relation, it's kind of like a discrete function, which means now that I have this table, for my domain, I just list what I have in my x column. So my domain here would be 4, 6, 0, -5. I don't know if there's anything in between that. I don't know if that's this is all I know. So this is all I can state. My range, I'm going to do the same thing, but I'm going to list the y's. Something to be aware of. I'm not sure if we were this cruel on the test or anything, but just something to be aware of. Sometimes you will see these not in the same order. Sometimes these will be in numerical order. Like it'll go -5, 0, 4, 6. And sometimes you'll see these in numerical order. Sometimes the coordinates will match up like they do right here. Sometimes they won't. But the idea is that the domain are these numbers. The range is these numbers. So I just want you to be aware that it might be in a different order. I don't think we were that mean, but you never know. All right. Let's see, let's push this up. So let's move on to 4 and 5. So number 4 asks to identify whether each graph represents a function. So kind of like number 1. If the graph does represent the function, is it linear? So let's look at A, graph A. So first we need to see if it is a function. And that means it has to pass the vertical line test. So if I look, it only touches the function at one point at a time. So yes, it's a function. It is a function. Is the function linear? Linear means the graph looks like a line, hence the word linear, like the word line is straight up in there. So is it linear? No, it's not linear. All right, graph B is the function. Well, if I take my ID, do my vertical line test, this is why you should bring your ID to school, guys. It only touches the function one point at a time. So yes, it is a function. Is it linear? Well, it appears to be a straight line. This is bothering me. Maybe it doesn't need the arrows, but it is kind of bothering me, so I'm going to fix that. Is it a straight line? Well, all lines are straight. I've been saying that all week. Is it a line? Yes. It is linear. Okay, and graph C. We're looking at it, yes, it's a line, but is it a function? And if I look, it's not going to pass the vertical line test because it's a vertical line itself. So if I were to draw a vertical line through it, it would touch like a gazillion points. So that is not a function. FYI, just so that we make this point, when you think about a slope, we've been talking about slopes of 0 and undefined slopes. So if a slope is undefined, that means that the equation that you've written for it is not going to be a function. So if you have an undefined slope, it is not a function. If you have 0 slope, though, like you did here, it is a function. I don't know that that's the most important thing in the world, but it's just something to think about. And you know what? The more math connections you make, the stronger you get at math. So sometimes these little asides can help. I don't know. Maybe I'm just a nerd and like to think of things. I don't know. Okay, let's look at number 5. All it says is identify the independent and dependent variables of the situation. So Taylor turns the garden hose on to fill up her pool. As time passes, water fills the pool. So what we would be comparing, the two things we're going to be comparing is the time that's passing and the water in the pool, like or how much water's in the pool. So which one depends on the other one? Does the amount of time we spend depend on how much water is in the pool? Or does how much water in the pool depend on how much time we've spent? And I hate asking those questions because I have to say them both ways and they never sound right. But if you think about it, time does not depend on, time's going to pass no matter what you're doing. So how much time you leave the water hose on is going to determine how much water's in the pool. Not the other way around. It doesn't make as much sense the other way around. So time here is independent. And water here is dependent. So yeah, I was gonna say something, but I'm trying to make sure what I put in these videos, I'm trying to make sure they make sense and don't confuse people. So I'm gonna stop there. So let's turn to the back of this page. We'll do the back of this page and then I'm gonna stop the video for today and I'll do like a part 2 later. Probably gonna end up having 3 parts because I'm looking, we've done 1 page in 15 minutes. So that being said, 6 through 9 goes rather quickly since it's all related to this one graph. Okay, so we're going to answer all these questions based off this graph. So 6, identify the y-intercept of this relation. So a y-intercept is where your function or your graph or your line, doesn't even have to be a function, but we're going to try to keep it to functions. But your y-intercept is where your function crosses the y-axis. So here's the y-axis. It crosses here. That point is -3. Your y-intercept is not -3. Remember, your y-intercept is a coordinate. So your y-intercept is 0, -3. Make sure that you emphasize that it's 0. This is a coordinate. A coordinate has an x and a y, not just a y. All right, 7, identify the domain and range of the relation. So let's look at domain first. Domain is every possible x value. So if I look, now these don't have arrows, so it doesn't continue. It stops here. So if I look, here's the x all the way over to the left. So I'm going to go up, and it goes from -9 to, it stops here, and that's +8. So my domain goes from -9 is less than x, is less than or equal to +8. And we're going to do the same with our range. We're going to go to our highest y value and our lowest y value. So my lowest y value, I believe, is this point as well. And that is at -9. There's nothing lower than that -9. And let's look for the highest y value, which I believe is right here. It's not perfect. I'm not sure if that was supposed to be 0 or if it's supposed to be a little bit over. So since it is a little bit over, I'm going to say about 0.25. Now, if you look at the key online later and it's not exact, if it's 0.5 or if it's 0, that's fine. I mean, there's some judgment call. We can't measure that. We would have to have the equation to know for sure. Graphs are a great tool till you get to something where you're in between 2 points and you can't really tell. So I'm going to say about 0.25, but somewhere close to that. But yeah, we're assuming there. So something I want you guys to realize, because I see this mistake every year and I see it multiple times throughout the year. When you write your domain and range, your variable should be in the middle, x for domain, y for range. Sometimes you'll have x and f of x. If you're measuring distance and time, you might have d and t. So the variable can change, but the variable should always be in the middle of these two. It shouldn't have, hold on one second. Okay. All right, so there's our domain and range. All right, part 8, or number 8, identify any relative maximums and relative minimums. Okay, so relative maximums, relative minimums are kind of the tops of these little humps, or the bottoms of the little humps. So if I want any relative maximums, so every maximum, we have one here, and we just want the y value. We don't want the whole coordinate. So the y value for this maximum is, we said, when we did our range, we said about 0.25. So here we're going to say 0.25. Okay, and then we have another maximum here, which is at about 2. And I believe that's it. Now, I know some people are going to be tempted to say, hey, wait a minute, right here. Oh, wait, that is -2. I apologize. Right here at -3, there's a maximum there, but relative maximums cannot be endpoints, so that cannot be a relative maximum. All right, so if we look at relative minimums, it's the opposite, it's the low points. So we have a low point here at -8. We have another one here at -5. And then again, you could call this a minimum, but relative minimum can't be an endpoint. All right, so then we get the absolute maximum and absolute minimum. Now these can be endpoints. They don't have to be the endpoints, but we're looking for the absolute highest maximum and the absolute lowest minimum. So if I look, my absolute highest maximum on this point, or on this graph, is right here at that 0.25. My lowest point at the graph is going to be right here at -9. I also want you to notice something about this. And I want you to look right here. And I want you to look right here. And I want you to look right here. And hopefully you make that connection. I don't have to spell it out for you. But I want you to look at that a couple of times and just kind of notice your minimum is your absolute lowest. Your maximum is your absolute highest. And your range is every possible y value from your lowest to your highest. Okay. So when I was working 7, I did get interrupted. I had to pause my video, and I got interrupted. So I think what I was trying to say was when you write these, your variable should always be in the middle, and you will always have less than signs. You won't have greater than signs. You should write them in order from the smaller number to the larger number. Put your variable in the middle, and it should be less than signs. I've seen all sorts of crazy things like x is less than a number is less than a number. And I'm like, well, that means x is less than both those numbers. That doesn't make sense. I've also seen 2 is less than x, which is less than -2. And I'm like, no, that doesn't make sense because you're saying 2 is less than -2, and that doesn't make sense. So make sure you put your numbers in order. Make sure you only use less than signs. A lot of people do a less than and a greater than sign, and that doesn't make sense because what we want to say is x is in between. So that means that 9 is smaller than x, and x is smaller than 8. So that makes x in between those two numbers. So that's why we use the same sign. A lot of people want to use opposite signs. So I think that's what I was trying to talk to y'all about before I got interrupted. And had to pause my video and lost my train of thought. So let's do number 10. And then I think that's where I will end it for this part of the video. And let's see, there we go. So I'll end it at number 10. And yeah. Okay, so number 10, it says graph the following functions by creating a table of input-output values. So we're going to create our table. We're going to have x and f of x, and our table should have -2x plus 1. Okay, so if we know how to graph this because we know slope-intercept form, but we don't necessarily know how to graph this. We haven't gotten to quadratics yet. We've talked about absolute value, but we haven't graphed absolute value. So if you don't know your tricks to graphing functions, which you wouldn't know these yet, we haven't taught these yet. If you don't know tricks to graphing a function, or if you're struggling to graph a function, you can always make a table of values. So I'm going to tell you you can pick whatever numbers you want for here. But usually if they give me 5 blanks, what I do is I put 0 in the middle. I do a 1 and a -1, a 2 and a -2. Sometimes I pick different numbers depending on the function, but all of these, I'm going to pick those same values. Again, you don't have to pick these. You can pick whatever values you want. But for all of these, I believe these are going to be our easiest. I believe these are going to be our easiest numbers. Okay, and actually what I think I'm going to do is I think I'm going to switch colors so you can see the difference between each function. So here we go. So we're going to plug in -2 for x. -2 times -2 is +4. Negative is positive. So +4 plus 1 is 5. I'm going to plug in -1. -2 times -1 is +2 plus 1 is 3. Then we're going to plug in 0. -2 times 0 is 0, plus 1 is 1. And we're going to keep going. -2 times 1 is -2. -2 plus 1 is -1. -2 times 2 is -4, plus 1 is -3. Okay, so we're going to graph this. So I have a coordinate at -2, +5, at -1, +3, at 0, 1, at 1, -1, and at 2, -3. So this is a linear function. I'm sure you could tell. You can also see the slope and the y-intercept. So the y-intercept is 1. Hey, the slope is down 2 over 1, which is -2. Hey, so we can also use that to finish graphing. We can just kind of follow our pattern. Should be a semi-straight line. I mean, all lines are straight, but there we go. So this is our graph of f of x, which means I made a mistake on these, because this should be not f of x, but g of x. Okay, we're going to follow this same pattern. So our function here is x squared minus 4. So we're going to plug in our x values, and we'll do the math and simplify. Just as a side note, if you are doing these in the calculator, make sure that the number you're squaring is in parentheses. I know a lot of you will say, but Miss Gallant, I can hit 2 squared and get 4. I don't have to do parentheses 2. And that's true till you get to negatives. If you don't put the -2 in parentheses, what it will do is it'll square 2 and then make it negative instead of squaring -2. It seems silly, but calculators are basically programmed, and when you program things, they speak a very specific language. So like one keystroke can make an entire math equation wrong or right. So you got to be very careful with a graphing calculator, or with any calculator. Okay, so -2 squared. So that means -2 times -2, which is +4, and +4 minus 4 is 0. Okay, -1 squared is -1 times -1, which will be +1. +1 minus 4 is -3. 0 squared is 0. 0 minus 4 is -4. Okay, 1 squared is 1, minus 4 is -3. 2 squared is 4, minus 4 is 0. Okay, so if I look at this, it's obviously not linear because I have multiple inputs that have the same output. So let's graph it. We have -2, 0. We have -1, -3. We have 0, -4, 1, -3, and 2, 0. So if I connect it, okay, so it doesn't make, it's not a linear graph. This is called a quadratic. It's that U shape. And mine looks a little more V-shaped, but it is what it is. So if I were to continue this graph, let's see. If I were to square 3, that would be 9 minus 4 is 5. So at 3, I would be at 5. Same goes true for -3. I would also be at 5. Let's see. And the next ones would not fit on the graph. So this is as far up as I can go. Okay, so there we go. That's going to have to be good enough. So this is the graph of g of x. Okay, and let's see, what other color do I have? Ooh, I've got hot pink. Let's do hot pink. All right, so our next function is the absolute value of 2x. Okay, so 2 times -2 is -4, and the absolute value of -4 is +4. The absolute value, we've got 2 times -1 is -2, but the absolute value of that is +2. 2 times 0 is 0. The absolute value of that is 0. 2 times 1 is 2. The absolute value of that is positive 2. I don't know why I was brain farting on that. 2 times 2 is 4. Absolute value of that is 4. So you can see our pattern is very similar to this one. Oh, goodness. It started raining like the bottom fell out. Oof. I don't want to walk to my car in that. Okay, so let's look at what we've got. We've got a coordinate at -2, positive 4. We have a coordinate at -1, positive 2. We have a coordinate at 0, 0. We have a coordinate at 1, 2. And we have a coordinate at 2, 4. And so we can connect them. Now I want you to notice something. This is absolute value. It is V-shaped. And if you notice, it's kind of linear, kind of not. Like it doesn't make a straight line. But if you look, doesn't it have a slope of 2 over 1? So I can continue this like you would a linear function. And on this side it has a slope, but it's -2 over 1. So it's just going in the opposite direction. So absolute value is kind of like that linear, non-linear. It's not linear because it doesn't graph a line. It graphs a V, but it's kind of like half of a linear equation and then another half of a linear equation. So it's not exactly linear, but it's not exactly not linear. I guess if you had to classify it's non-linear, but it has linear properties. It's kind of fun. Okay, so you made a table of values, we got our graphs, and we are good here. So this video is already 30 minutes long, so I hope you are comfy and that you got comfy and that you got through this. I'm going to stop the video here. We'll do a part 2 in a minute. Make sure you've got a comfortable seat because that one's probably going to be long too. Y'all have a good evening, and I'll record in a little bit.